In question number 11, the diagram shows the curve, the graph of y equals to 5 sine 2x cos square x and its maximum point M. We have to find the exact x coordinate of M. Now, as it's a maximum point, we know that dy by dx would be equals to 0. And as the terms are multiplying, we'll use the product rule. So u, we can take it as sine 2x and we can keep 5 common. So u dash, or the derivative of sine 2x, would be 2 cos of 2x. V will take as cos square of x, and when we differentiate v, so 2 will multiply, so we'll get 2 cos of x, and the derivative of cos x is minus sin x. We'll get minus sin x, or we can write it as minus 2 cos x sin x. Now applying the product rule, you'll get vu dash plus uv dash. So this is u dash and this is v dash. So vu dash would be cos square x into 2 cos 2x. So cos square x into 2 cos of 2x plus uv dash. So that will be sine of 2x multiplied by minus 2 sine cos. And then the whole expression is multiplying by 5 over here. So we'll get 10 cos square of x cos of 2x minus sine 2 of x into 2 sine cos. Now to make this positive, we can, and we'll put it equals to 0 as it's a maximum point. We'll take it on the left hand side, we'll get sine 2x into 2 sine cos is equals to 10 cos square into cos of 2x. Now to solve this equation, well, I think we can cancel this cos and cos over here, and cos of sine 2x upon cos 2x, we can write it as sine 2x upon cos of 2x, and 10 upon 2 will become 5, and this is cos upon sine. So this will be tan of 2x is equals to 5 upon tan of x. Now to solve this, what we'll do is we can use the identity over here for tan of 2x. That is basically 2 tan of x upon 1 minus tan squared of x, and that is equals to 5 upon tan. Now cross multiplying, we will get 2 tan square is equals to 5 minus 5 tan squared. So 2 tan squared plus 5 tan squared, that will make it 7 tan squared equals to 5, and tan squared would be equals to 5 upon 7. And just one correction, we did not multiply the 5 over here. So we had to multiply by 5 over here as well. This would have been a 5 over here. This would have been a 5 over here as well. So this would become 5 times 2. So this would have been 5 into 2 tan upon 1 minus tan square equals to 5 upon tan. So now if I cross multiply, that would become, so 5 times 2 is 10. So 10 tan square is equals to 5 minus 5 tan square. So that will be equals to 15 tan squared equals to 5. And finally, I can write tan squared of x equals to 5 upon 15, which is equals to 1 upon 3. And now finding the value of x, so we'll do shift tan inverse of root 1 upon 3. So x would be equals to tan inverse of root 1 upon 3. So shift tan inverse of root 1 upon 3, and that is equals to pi upon 6. So the x coordinate would be pi upon 6. Now in part B, by using substitution u equals to cos x, we have to find the area of the region bounded by the curve, the x-axis, between these 2 points and the line x equals to 1 upon 4 pi. So the equation is 5 sine 2x cos square x. So we have to integrate with the limits 1 upon 4 pi and 0. And our equation is, again, what is it? 5 sine 2x. So that is 5 sine 2x into cos square of x dx. Now whenever we are using substitution, the first thing we do is we find du by dx. That would be equals to minus sine of x. So dx would be equals to minus du upon sine of x. So in place of dx, we will write, and in place of sine of 2x, we can write 2 sine cos as the identity. In place of cos square, we can write, well, we can write already. And in place of dx, we'll write minus du upon sine of x. So this will cancel out. And in place of cos, we will have u. So this will become 10 into u cube. And there's a minus sign over here, du. And now we'll change the limits as well. So u is equals to cos of x. So we'll write cos of 1 upon 4 pi. So u would be equals to, now cos of 1 upon 4 pi, if we substitute this in the calculator, that is equals to root 2 upon 2. That is basically 0.707. And when we substitute cos of 0, that is equals to 1. So we are getting the upper limit with the lower value, which basically changes the sign over here. So we can remove the sign and write it as 1 and root 2 upon 2 as our limits. Now integrating 10u cube, we'll get 10u power 4 upon 4. 10 upon 4 is 5 upon 2. We'll get 5 upon 2 u to the power of 4. And we have integrated this. Now we'll plug in the limits. So the first limit is 1. Yes, the first limit is 1. So we'll get 5 upon 2 into 1 minus 5 upon 2 into root 2 upon 2 to the power of 4. So root 2 to the power of 4 basically means power half into 4. So that will become 2 squared. So we'll get minus 5 upon 2 into 2 squared upon 2 to the power 4, which is 16. And this 5 upon 2 remains as it is. And then finally, simplifying this, we'll get 5 upon 2 into 4 upon 16. This will cancel out. We'll get 5 upon 8. So 5 upon 2 minus 5 upon 8, multiplying this by 4, we'll get 20 minus 5, which is 15 upon 8 as the area under the graph for the limits pi upon 4 and 0. So the final answer will be 15 upon 8.